Hello all. So, paper is from IEEE Transactions on Plasma Sciences. The topic is enhanced radiation characteristics for Vivaldi antenna using scoop surface plasma polarity. This is the abstract. The traditional Vivaldi antenna is well known for its ultra-wide bandwidth but low gain. To enhance the radiation characteristics, we propose a new method by adding an additional structure that supports spoof surface plasma polaritons as the parasitic elements. So here the authors have tried to combine two concepts. First one is the Vivaldi antenna. They are using it to get wide bandwidth and to compensate the low gain. They have they are using the concept of spoof surface plasma polarity. The proposed patch has an enhanced gain over whole frequency band without deteriorating the bandwidth. So this was the target statement. They wanted to maintain high gain without compromising the bandwidth. The Sommerfeld, the Sommerfeld-Zenek wave mode and slow wave mode benefit the gain and realize better directivity. Here, this is an important statement because they are diving deep into the basics of the concepts. Means that they are showing that this spoof surface plasma polariton addition is enhancing the gain of the whole system. But how? So this is the concept. Sommerfeld-Zenek wave mode and slow wave mode benefit. These two modes are being activated. The maximum gain could improve as high as 5 dBi. So 5 dBi for a ultra wideband antenna is really a big gain. Several measured results are successfully confirmed with simulations which demonstrate the higher directivity in the end fire direction. So as we are aware that Vivaldi antennas are for end fire radiation. So here also it is the same. The design method provides a new method to improve the radiation characteristics for Vivaldi antenna. Here they are adding this parasitic patch, the spoof surface plasmon polaton. So they are showing that it is the new method. So basically they have combined two concepts to create a better version of Vivaldi antenna. Let's go into the introduction. With the rapid development of the imaging system, microwave measurement technology and radars, ultra-wideband antenna has been widely researched. So ultra-wideband antenna is the thing they are saying that it is the need of an hour. Numerous types of wideband antennas have been mentioned. The most classical antenna is the Vivaldi antenna because of its low fabrication cost, lightweight, and ease of integration. So these are some positive points related with Vivaldi antenna. It operates by coupling traveling wave along the flared slot. It operates by coupling traveling wave along the flared slot aperture and producing endfire radiation. So this is an important statement related with Vivaldi antenna. This is related with the basic principle of Vivaldi antenna that it operates by coupling traveling wave along the flared slot aperture and producing endfire radiation. However, as the frequency increases, it may suffer from beam tilting, side lobe level, and pattern distortion. In recent years, several novel methods have been reported. So here, this statement is yet another an important statement. Why it is important? Because it gives us the the opportunity to do research. Someone is working on Vivaldi antenna, then he should be focusing on this thing. Uh, if as per the nature of the Vivaldi antenna, he will be getting as we can see here, beam tilting and high side lobe levels for high frequencies. So he should be having some mechanism to keep the beam straight. I mean, the tilt should be as minimum as possible, and he should be having some mechanism to improve side lobe levels apart from, and pattern distortion also. There should be some mechanism added to improve pattern distortion. In recent years, several novel methods have been reported to improve the radiation performance of the Vivaldi antenna. For example, directors are commonly employed to get higher gain and better pattern. So they have discussed some commonly available solutions also for the same thing. So one of them is employment use of directors. A dielectric structure can be designed as the directors. So they have taken some references. Here another important thing is while writing introduction, uh, writing it this way that just making writing a statement and then writing a reference that from here you've got this information. So this is a better way. I mean, instead of writing that in this reference authors have said that, in that reference authors have said this or done this. So instead of that, this should be a better way to write introduction. Apart from this, we see here a dialectric structure can be designed as the directors. So a simple statement. They are not saying that the authors have done this or that. They have just given a statement and they have taken some written some references on which they have observed this thing that the directors can be used to improve the performance of the Vivaldi antenna. Now here they are writing it in a typical way that in 6 and 7 anisotropic zero index metamaterials were inserted in the aperture to improve the gain. Now this is a standard statement. Usually people write the literature survey in the introduction like this. So, but we should be having some alternate ways also. Well, so the statement was a dielectric structure can be designed as the director. So here, first they said that directors can commonly be used to improve the performance, and now the directors can be made up of dielectric structures. So this was the second statement. So we can underline this also. Then in 6 and 7 anisotropic ZIM. Now zero index metamaterials ZIMs are also, ZIM is a very important term in the field of metamaterial and metasurfaces. So zero index means the refractive index of the material is zero. So anisotropic zero index metamaterial. Anisotropic means a system in which the performance uh, doesn't depend upon the direction, were inserted in the aperture to improve the gain. So anisotropic zero index metamaterial were inserted in the aperture to improve the gain. So this is a standard way. Now Vivaldi antennas with a double slot structure were reported to obtain remarkable directivity. Now this is another statement. So this is a better statement than in this or in that. Authors have done this or authors have done that. Vivaldi antennas with a double slot structure were reported, simple, that it were reported to obtain remarkable directivity. So they have shared that double slot structure is a significant concept. A corrugating order, a corrugating outer edge was also used to improve the radiation pattern. Nice. So this is yet another better way to write the literature survey according to 11. Now this is also something different. According to 11, the slot edges inhibit the surface currents in the edges of the antenna in order to reduce the side lobe level. So here they have just written the conclusion from a particular paper. According to 11, the slot edges inhibit the surface currents in the edges of the antenna in order to reduce the side lobe level. In addition, a substrate lens and a metal director are used to improve the directivity characteristics. In addition, a substrate lens and a metal director are used to improve the directivity characteristics. So substrate lens is a standard way, and metal director is also, as we have seen earlier in this literature survey, that it is also a standard way to improve the performance of the antenna. So they are just saying it again here. The gain is about 4 dBi higher than the original antipodal Vivaldi antenna, but the processing is more complicated. So here, I think they are talking about this 11th 11th journal. Here they have explored it in depth. First, they have talked about the concepts uh, being used to improve the performance. Apart from that, what are the what are the negative points associated with that? So they are saying that the complexity is thick, important. Moreover, adding a parasitic element is an effective way. So yet another concept they are sharing, including elliptical patch and optimization structure. So this is yet another way of writing the literature service statement, that they are giving a statement that adding a parasitic element is an effective way to improve radiation performance, including elliptical patch. Now, this elliptical patch is uh, have must have it have been used in this reference, and optimized structure is have been used in 13th structure. So they are just naming it, naming the papers and the concepts being used. However, most designs are costly. Now, this is a generalized statement, so they are moving towards conclusion of the introduction. So this is the conclusion statement of the introduction, that however, most designs are costly, complex, and can only improve the performance in an element. So here we find the proper way of writing literature survey. Write it in some different ways, better ways, and then try to be generalized. Means here we can see that two or more than two literature papers have been reviewed in a single statement or a double statement. So this is a better way of writing a literature survey. Apart from that, the important thing is to end the literature survey in the introduction. However, most designs are costly, complex, and can only improve the performance in a narrow band. So in this simple statement, they are saying that what are their target points. So the points are cost, complexity, and apart from that, they are saying that improvement is usually done in the narrow band performance, not in the wide band or broadband. This way, we should terminate or conclude the introductions literature survey portion. And apart after this, we should start this bracket in this article. So in this bracket, usually we discuss about the work we have done in this article. So that's why it starts it in this article. An enhanced radiation Vivaldi antenna with a spoof surface plasmon polariton patch is present. SSPP, spoof surface plasmon polariton. So here they are saying that they have used the concept of spoof surface plasmon polariton to improve to enhance the antenna radiation characteristic. Now they are talking about SSPP as it can be guided by structured metals at microwave and terahertz, whose dispersion characteristics are analogous to conventional surface plasmon polariton. So why SSPP can be used or should be used? So they are giving this reasoning. Why? So its dispersion characteristics are analogous to conventional surface plasmon polaritons in optical range. So this is yet another part of literature survey. Now, usually people think that literature survey should be first done completely, then the in this article para should be started. But here they have divided the literature survey into two parts. First part was related with Vivaldi, and then in this article part also having literature survey, and in this they are discussing the concept they have used to improve the Vivaldi. So that is SSPP. So dispersion characteristics are analogous to conventional surface plasmon polaritons. This thing in the optical range, this thing they have learned from 14 to 16. Now, due to slow wave property, SSPP have been used to produce compact components in wireless communication systems in the micromillimeter range. So now they are again giving the concept behind the improvement caused by SSPP. So why SSPP improve gain? So they are saying that the slow wave property of the SSPP is responsible for compact structures with better performance. Now, the applications include, so why people use SSPP? So they are saying that the applications include filters, power dividers. Now look at this way of referencing. This is a single statement: filters, power dividers, circuits, couplers, antennas. In this single statement, they have referred 17, 18, 1924 and 37 or 18 or 19, 9 and 11 here. So it is around 20 papers. So they have referenced 20 papers in a single statement. So this is also yet another way of writing literature survey. So for that, we should be able to frame such kind of statement that the applications include. So for an applications point of view, they have covered these papers. In addition, the plasmonic structures have been proposed to coverage the electromagnetic waves and enhance the gain of the antenna. So in this paper, they have learned that the plasmonic structures can be used to improve the gain of the antenna. However, the design requires, so yeah, yet another important remark that to connect statements from one another, we should use these kind of connecting I say connecting words, yes. So, however, moreover, these are some important statements. The design requires double-phased SSPP structure and further fabrication process and cost, which form an equivalent dielectric stack to realize graded index dielectric lengths. So now here, this is an important statement. Why? Because they are not only talking about the concept they have utilized, they are talking about the options also, that the design requires that double-phased SSPP structure. So apart from this thing, what they are saying, that which form an equivalent dielectric stack to realize graded index dielectric lengths. So they are talking about dielectric lengths also. That dielectric graded index dielectric lengths is realized using SSPP structure. So one can make the same graded index dielectric lengths to improve the performance of the antenna. So they are achieving this behavior through SSPP. Here we combine a traditional coplanar Vivaldi antenna and a parasitic element together by using the odd mode SSPP in the element. Now, yet another informative statement. They are giving information that they've used the odd mode SSPP in the element, and they have achieved high gain and directivity. So this is a way of writing statement. It should be informative. Every statement you're writing, it should add the information to the overall paper. The ultra wideband characteristic is well kept after inserting the patch. A wide bandwidth as high as 130% is obtained. So this is the accomplishment statement. So one should write this also while writing the in this work or in this paper paragraph. The realized gain has been improved over whole operating band and the gain peak has been enhanced significantly greater than 5 dB. This is also an important statement. So what were the important contribution of the work? So that should be written here in this work paragraph. So this way in this work paragraph ends. Now antenna configuration, design and mechanism. So this is the second part of the paper. Antenna configuration, design and mechanism. So here in design and mechanism, what they are showing. Configuration of the antenna. Here in configuration, they are showing proposed antenna configuration in figure 1. So we see here, this is the figure 1, the Vivaldi antenna structure. This first figure is shown in the configuration. So the antenna is fabricated on the, they are giving general information about the antenna they have designed, that the size of the antenna is this, F4B substrate is used, permittivity is this, loss tangent is this. It can be divided into three sections termed as feed line. So Vivaldi antenna, they are talking about, it can be divided into three parts: feeding line, flared slot radiator, and parasitic patch. Microstrip line with 50 ohm is designed as a feeding line, which has a width of this 1.4 mm and a fan shaped tuning stub. Now you see, at the end of the Vivaldi, they have used a stub. They are giving information why they are using that stub. So fan shaped tuning stub. In this single word tuning stub, they have said that they have used the stub to improve the tuning. By combining microstrip line with the circular cavity, TEM mode in a microstrip can be transformed to differential mode in the slot line. Now this is yet another important statement, that by combining the microstrip line with the circular cavity, TEM mode in microstrip can be transformed to different differential mode in the slot line. So try to be as much contributing as possible. Now, by reading this statement or by observing it properly, we can learn that this is a conclusive statement. By combining the microstrip line with circular cavity, what happens? So it converts the TEM mode to differential. The minimum distance of the slot aperture is 0.2 mm. The design of the flared slot radiator is defined as this. So this is the flaring equation where the tapered arm meets the substrate edge. A parasitic structure is inserted into the slot aperture. Oh, I think these two statements should be connected. Where the tapered arm meets the substrate edge, a parasitic structure is inserted into the slot aperture. The fields are coupled between the flared aperture and the parasitic element. Now again, this is a conclusive statement, or the findings they have shared, that the fields are being coupled when the flared aperture meets the parasitic element. This improves the gain and the directivity. So these two statements are important statements, because these statements show that they are aware the reasoning behind improvement in the antenna characteristics. So we should be having such statements to justify the knowledge we have about the improvement in the performance. The optimized dimensions is presented in the antenna. The optimized dimensions of the presented antenna are tabulated in table 1. Now this is an important way of writing the dimensions of the antenna. Try to write the dimensions this way, tabular way. Though it consumes some portion of the paper, some extra portion. Means if it could be written in statement, it could take 2 or 3 lines, but here it is taking around 8 to 10 lines. That's why I think they are writing this paper uh, for a transaction, because we can see that it is a 7 page long paper. There the references are in the 6th and 7th page. Still, it is not very long. The paper is concluded in 5 pages only, so not too long. Now we go to another part. So in the antenna configuration, design and mechanism part, first they have explored the configuration and the structure, and then mechanism, design and mechanism. So in the mechanism, they are exploring the operating principle. In this section, the microstrip to slot line transition is studied. So this is an important study. while doing this kind of research where two things are merged to improve something, it should the study should be in detail. So that's what they are doing, that this transition is studied and the parasitic element and the radiation improvement mechanism are analyzed. So this study and analyzing stuff should be there while writing the paper. Now, microstrip to slot line transition. The transition is composed of two parts: open-ended microstrip line, a short-ended slot line. Microstrip to slot line transition. To elaborate this design, the microstrip to slot line transition can be modeled as an equivalent circuit. Now, this is yet another strong way of explaining a stuff by making or using other ways, such as this equivalent circuit model here. Now they have tried to calculate L and C. L and C are the inductance of the shorted slot line and the capacitance of the open microstrip respectively. ZS and ZM denote the slot line and microstrip line, I think. Yeah, impedance respectively. Zant is the antenna input impedance of the antenna, which is approximately equal to Zs. Theta is the electrical length of the diameter of the circular cavity. Theta m is the electrical length of the radius of the fan-shaped stub, and is the transformer ratio. So here they have given the reference also from where they've learned this way of analyzing. This is an important contribution. First, they have explained it, what they are doing in this equivalent circuit modeling, and then they have given the reference from where they've learned this. If someone is interested in further study of this thing, they can refer this paper. And here we can see the circuit model representation of the proposed transition. We see here this way. Here a transformer is being used, so this way Z is Z naught is being transferred to Zm is being transferred to Zs or Z, yeah, Zs. And both the theta s and theta m are equal to a quarter of wavelength. Open microstrip and shorted slot line are transformed into a short termination and open circuit respectively. Then the reflection coefficient can be written as this. So again, yet another important paragraph it is. This is the kind of research portion which should be added to the support the modifications or the techniques we have used to improve our antenna performance. The transformer ratio N is associated with the size of the two transmission lines and the permittivity of the substrate. Yet another depth depicting statement. Therefore, the reflection can be adjusted to be 0 by simply altering the width of the slot aperture, which changes the slot line characteristic impedance Zs and makes n square Zs equals to Zm. So yet another important statement. By further simulation optimizing, the related parameters can be obtained as shown in table 1. So very important part of the manuscript. Parasitic element. First part was to convert microstrip line to slot line transition. Then the second part is parasitic element. The parasitic element consists of a row of corrugated metallic unit cells. Periodicity of a unit cell is this. Groove width is this. The corrugated metal structures can support both even and odd mode as PP. Now, yet another detailing statement about the modes of the SSPP, and they have given the reference to it. So this is again a better way of writing a paper, that whenever they are using something new, they are giving a statement and showing a paper or referring a paper specifically. Figure 3a denotes the even mode whose surface currents are symmetrical along the y-axis. The electric currents and the field distributions of the odd mode are shown in figure 3b. So even mode and odd mode analysis is done there. We can see A and B, even mode and odd mode. So here they are giving the justification about the mode they have used. It can be observed. Now they are showing their observation. They are writing their observation. It can be observed that the currents are all heading in the same direction, which are asymmetrical about the y-axis. So this they have concluded for the third B point. Figure third C, 3C. So we see here that there are four figures A, B, C, D. So figure 3C shows the dispersion curves of the odd mode with various group depth, and figure 3C as the from figure 3C as the wave number increases, the dispersion curve moves away from the light line and approaches the asymptotic frequency, which is similar to natural SPP in optical band. So here they are, since they have talked about spoof surface plasma polariton. So if someone is talking about spoof surface plasma polariton, then he must be making or plotting these curves, frequency versus wavelength curves. That's what they are, wave number curves. That as the wave number increases, wave number means this kp by pi. Kp by pi is the wave number. So as the wave number increases, this frequency is going away from the light line. This is the light line. So what is the conclusion they are trying to give with this statement? That with the increase in the wave number, frequency shifts away from the light line, the dispersion curve moves away and approaches asymptotic frequency. And they are saying that this is the similar behavior which can be achieved using natural SPPs in optical band. So that's what they are achieving using spoof surface plasma polaritons also. So meanwhile, it is observed that cutoff frequency with smaller depth is higher than the one with larger depth. So this is another conclusive statement of their observation. So what is observed? So these are the things, important things. When you give some plots, so first give the reason behind plotting it. So they have given that spoof surface plasma polariton behaves like uh, normal surface plasma polaritons, right? So that's why they are measuring or providing a scale of same observation, that wave number versus frequency plot. And then they are writing the conclusion, the observation also. It is observed that the cutoff frequency with smaller depth is higher than with the larger depth. So this was the statement they have concluded from figure 3C. We should be writing these kind of statements also to, to conclude the observations. Nevertheless, at lower frequency region, all curves overlap with each other. So this is the way of explaining or writing the observation. From the relationship between dispersion curves and the light line, the dispersion can be divided into three regions: the fast wave, Sommerfeld-Zenek wave region, and slow wave region. So this is also the same 3C plot, 3D. It is 3D. We can see here they have taken this frequency versus wave number curve, and it is divided into three parts with respect to frequency. We see from 0 to 5 or below some frequency 5, 4, around 4. It is fast to, it is called fast wave. Then after with up to 10 or 10, 11, it is called Sommerfeld-Zenek wave, and after this it is called slow wave. So this is yet another observation of them, and they have explored this. So they are explaining these things as as mechanism information. From the relationship between dispersion curve and outline, the dispersion can be divided into three regions. In the fast wave section, the dispersion curve is on the left of the light line and at lower frequency region, while the slow wave section is on the right and at higher frequency region. The Sommerfeld wave is denoted denotes that the propagation constant k is close to k naught at the free space, and the waves can extend over many wavelengths into air. So this is what they've observed from this figure, this paper also. So here also they've given the observation references, observation as well as reference. So this is a better way of writing operating principle and mechanism. Now take h equals to 3 mm as an example in 3D. So here they have now started talking about 3D. The fast wave region ranges from this to this, and then the Sommerfeld Zonic region is from this to this, and the slow wave region is from this to this, which means that the wave number is larger than the light line. So this was a better way of writing this portion. Now the third part, so they have initially said that in this section the microstrip to slot line transition is studied first, and then the parasitic element and the radiation improvement mechanism are analyzed. So microstrip to slot line transition and parasitic element is studied, and now they have analyzed the radiation improvement mechanism also. So this is a better way of writing a paper, that you give detailed analysis of the mechanism as well as operating principle, design as well as mechanism. So this detailing is required to write a good paper. Coupling between Vivaldi antenna and parasitic element. So let's see what they have to say about this thing. In the Vivaldi antenna, the phase difference between the waves traveling on inner slots is 180 degree, and the electric fields are perpendicular to the metal edge as shown in figure this. So the first statement, yet another, is an informative statement and an important statement. It's not a general statement that these are the things happening here. So it's something which they have learned after reading literature about the Vivaldi antenna, and they have tried to concisely give this information with this simple statement, that the in the Vivaldi antenna, the phase difference between the waves traveling on inner slots is 180 degree, and the electric fields are perpendicular to the metal edge as shown in figure this. As illustrated in figure 3b, the electric currents of the odd mode are along the operating direction. So due to the similarity of the electric field distribution in the aperture of the Vivaldi antenna and on the groove of the unit cell, the fields can be coupled from the flared slot radiator to the odd mode SSPP as illustrated in figure 3b. So here in this part of the paragraph, they have given the justification why they have said that the odd mode SSPP is used. So the justification is that the electric currents of the odd mode are along the opening direction. Let's see here in 3b. So the 3b figure, yeah, this is the 3b plot. Now they are saying that the direction of the arrow is in the opening direction. It's tough to understand. Yet, uh, still, this way they are giving the reasoning that the direction of the arrow here, as illustrated in figure 3b, the electric currents of the odd mode are along the opening direction due to the similarity of the electric field distribution in the aperture of the Vivaldi antenna. This is the reason. The similarity of the electric field distribution in the aperture of the Vivaldi antenna and on the groove of the unit cell, fields are coupled. So this thing they have observed, or they think that this is the reason. They may be correct, but they should be. This is the way of writing these statements. This is something we should learn. From figure 3c, we found that the wave number of the SSPP unit cell can be controlled by changing the height h. So here in 3c they have varied the height also, and that's what they have said. This is another observation, that by varying h they get different curves. So yet another observation. So we see that there are no loose statements. Every statement is uh, important and informative. From figure 3c, we found that the wave number of the SSPP unit cell can be controlled by changing the height. So this is something they have found. As the value of h decreases, the wave number approaches the light line. This is what? This is the observation. Yet another observation. In this way, the gradually deepened grooves can compensate for the poor phase matching between SSPP and quasi-TEM mode. The gradually deepened grooves can compensate. We see that the grooves are being deepened gradually or not. So we can see it here. Yeah, you see the grooves are small and then it is getting bigger and then it is remaining bigger. After some time it gets smaller. I think that's what they are saying here, that gradually deepened grooves can compensate for the poor phase matching between the SSPP and quasi-TM mode through the cooperation of the exponential slot line and an array of gradual change grooves. The waves generated by the flared aperture can excite the odd mode SSPP in a parasitic element. This is a better way of explaining the stuff. Compared to excitation using a monopole antenna in 2124, this proposed feeding method has higher efficiency. Now, this statement is very important. Here, they have compared it with other works also, and they are they're showing that that their concept is better way of doing it. So, yet another informative paragraph. It was. Now they have given the fourth part, analysis of the radiation improvement mechanism. So you see here, I think the USP of this paper is this portion only, the design and mechanism portion. Here they have shared all the things they have observed. Analysis of the radiation improved mechanism. Instead of having the radiation only operated by the slot in a conventional Vivaldi antenna, the fields coupled to parasitic element and converge the wave in the entire direction. Instead of having the radiation only operated by the slot in a conventional Vivaldi antenna, the fields coupled to the parasitic element and the coverage and converge the fields coupled to parasitic element. Means that's what they are saying, that they are talking about fields. That the instead of having radiation only operated by the slot, so only the slot is not operating the radiation. Fields coupled to parasitic element is also acting here and converge the wave in entire direction. So important statement. From the dispersion curve of the SSPP, three guidelines are concluded. Now they are sharing the conclusion for the radiation mechanism of our proposed Vivaldi antenna. So we should be writing our findings this way also. Okay. Now what are these findings? So they have given these findings. You see, they have so much to share. First, as shown in figure 3c, the fast wave region is from this to this. In this region, the momentum k is always smaller than k naught regardless of the group depth h. So this is a conclusion. Uh, they have they have earlier also talked about 3c, but they have not discussed it in these words. So this is another way of explaining figure 3c. So this is important, that if you think if there is any better way of explaining or connecting the research or the analysis you have done, so you should do it. It means it means first they've given a statement and then they are trying to explain it in a better or easy language. It means that there is momentum mismatching between SSPP and the quasi-TEM mode. So first they have said that the momentum K is always smaller than K naught, regardless of the group depth. So by reading this statement, it is quite possible that people may not get this statement that there is momentum mismatch, but that's why they have written it clearly that there is momentum mismatch. Therefore, so by momentum mismatch, the fast wave mode cannot be excited directly, and the parasitic patch has little effect on the radiating fields from the flared aperture. So yet another important statement that that's why this fast wave mode is not excited directly. To demonstrate this effect, the near electric field EY in the XY plane at 3 GHz with and without parasitic elements was calculated as seen in figure 5b. So you see the they have calculated electric field, so they are giving the reasoning behind that also. Why they have calculated electric field? To demonstrate this effect. Which effect? This effect that the fast wave mode cannot be excited, and the parasitic patch has the little effect on the radiating field. So to demonstrate this effect, near electric field EY in the XY plane at 3 GHz with and without parasitic elements is calculated. As seen, the patch makes no response to the electric field, and they have concluded this thing from figure 5b. So let's see 5b. Figure 5a is this, figure 5b is this. We see this is comparative analysis. Vivaldi without parasitic, Vivaldi with parasitic. So at lower frequency, no change. So that's what they are saying. The patch makes no response to the electric field. Compared with 5a, the two distributions have little difference. Oh, yeah. Therefore, the radiation characteristics are primarily determined by the original Vivaldi antenna in the fast wave region. Again, reasoning behind the analysis, why they have done a certain analysis. So therefore the radiation characteristics are primarily determined by the original Vivaldi antenna in the fast wave region. Next, so this was the first part of the explanation they have. Next, the Sommerfeld Zenek wave region is from this to this. In this band, the momentum is close to K naught, which cannot confine the energy flow to an area that is localized at the corrugated structure. Again, an informative statement. In this band, the momentum K is close to K naught. This could be a simple statement, means only people may write this only, that the momentum K is close to K naught. But further, they have written that it cannot confine the energy flow to an area that is localized at the corrugated structure. Now, this is informative. Although most of the energy of the wave is not near the structure, parasitic element still serves to guide the radiation wave. Although most of the energy of the wave is not near the structure, parasitic element still serves to guide the radiation wave to end-fire direction. Now here they have given what? The significance of the parasitic structure. To demonstrate our prediction, figure 5C and D shows the electric field. So again, to demonstrate our prediction. Now you see here that this is the reasoning behind the analysis done in figure 5C and D. So this is a better way of writing statements or connecting or creating the flow. This is what a word flow means in a manuscript. People may give review comments as the flow is missing in your work. So this is the thing they are trying to say, that why you are doing certain things, what is the reasoning behind it, what are the conclusions, what are the observations, what are your predictions, were they fulfilled or found correct or not. So these are the things which makes the flow, right? As seen in figure 5D, there are fields coupling to the SSPP and the field confinement in the corrugated structure are weak. So they are now talking about 5D. So we see here earlier for the fast wave region, there is no significant change with and without patch. But when we talk about Summerfield region, we see that in this region and this region, so here the patch is having some role, not exactly undifferent. It is playing some role, not active role, but some role. And we see in figure F that compared to E, that for the slow wave frequency, the parasitic element or the SSPP is playing very crucial role. You see here that it is actively radiating at this frequency. As seen in figure 5D, there are fields coupling to SSPP and the field confinement in corrugated structure are weak. So we see earlier there was no confinement, but here it is there but weak. In addition, the amplitude of EY is gradually decreased. EY is decreased, implying that the surface wave is Sommerfeld Zenek wave. So you see here they have concluded this thing also. This is important statement. So we see that every paragraph is having very strong statement, and every paragraph is helping us to get better understanding of the work they've done. Compared to 5C, we can clearly observe that the electric fields are more focused in the middle region of the slot aperture in the 5D, while less field distribution on the flare termination section that results in high directivity. So again, why the directivity is high? This question is being answered here. So better way, good way of writing such conclusions. So they have concluded from these electric field plot, that this is the reason they have achieved high directivity. Compared to 5C, we can clearly observe that the electric fields are more focused in the middle region of the slot, while less field distribution on the flare termination section. So earlier the directivity was small. Why? Because fields was going to the flare termination. This is the flare. So flare termination was responsible for lesser directivity, but since they have used this SSPP, so more field is focused at the center than the termination of the flaring. That's why the directivity is improved further. So this is what they have concluded here as well as here in in both these things. You see here, this weak electric field attachment is having generating better directivity, and this thing is further improved for at high frequencies. So that's what I think they are trying to conclude. Therefore, the parasitic patch benefits to radiation characteristics in the Sommerfeld Zenek wave region. So here they have said that in this region they get a better directivity, and finally for slow wave range region, the dispersion curve approaches the cutoff frequency when the wave number k keeps increasing. Now, according to theory shown in this, so again better way of writing or showing giving their observation, have some reference with you so that it makes better impact. The region on the right of the light line denotes the propagation region in which the surface wave can travel along the parasitic patch. So this statement they have observed from this paper and they have written it here. We can also consider this mechanism as a dielectric lens. They are comparing this patch as a dielectric lens. In this band, the propagation constant of SSPP will be larger than the light in the free space, implying that the patch has higher effective refractive index than vacuum index. Therefore, SSPP will, with slow wave, take a role of a lens to Vivaldi antenna, and most energy focus around the element, improving the gain of it. Very good way that people are aware that dielectric lens can improve the directivity and gain of a Vivaldi antenna, and now they have proved, or they have just justified that the SSPP parasitic patch they have used is acting like dielectric lens, and hence it is improving the performance. The right tapered end in the proposed antenna is a transition to free space, making a better phase matching and higher radiation efficiency. Again, a better way of writing the achievements or the findings. So you see, they have explored many things in this design and mechanism part only, and some very important thing. I mean, we can say that the soul of the paper. So refer to figure 3b. The direction of odd mode currents on each metal strip is same along the y-axis. Hence, the odd mode electric field EY near the up and down grooves have same phase, while the even mode has reverse distributions. You see here, they are not in hurry, or they are not hastily skipping any information, or they want things to be explored at as much depth as possible. This should be adapted from this manuscript, that one should write a paper this way. Figure 5F is given to show that the simulated near field at 14 gigahertz. To show the simulated near field at 14 gigahertz, the electric field near the narrow slot implies that the SSPP is the odd mode. So here they are justifying why they are calling it odd mode. The electric field EY near the narrow slot imply that SSPP is the odd mode. At the same time, electric field amplitudes on the parasitic structure are nearly equal. Their results suggest that the odd mode SSPP can propagate well in the passband. Again, a conclusive statement. Very good way of writing the work. At the right end, the SSPP waves re-emit by adding the tapering end. We can also find a remarkable difference between 5E and FES. So there it can be seen that the spherical like waves are obtained that result in low directivity in 5E, while our proposed antenna generates plane like waves producing high directivity. This is one important statement. They are not just simply saying that this their their version is improving the characteristic. They are writing it in a more sophisticated way by saying that the spherical wavefronts are being converted to planar wavefronts. So this is a proper way of justifying that this way the directivity is being improved. They have given the fifth point also, structure parametric study. So they have added this also. The size of the parasitic patch also affects the radiation characteristics. The influence of the length SS, LSPP, LSSPP are investigated for final designed antenna. So you see they have not skipped anything. The parametric study is shown as seen the length has a great influence on the antenna gain. At lower frequencies, the gain has small improvement, and as L increases, however, each additional 25 mm of length adds 1 dBi to realized gain after 11 GHz. So this is what they found after doing the parametric study. So now again a good way of writing the achievements or the findings. This was all from the second part of the paper. Now the third part is performance of the proposed antenna. So till this part we have not discussed the S11 and gain, means how the values are there, how much values are there. They have just explored the mechanism, and they've given two important pages to design and mechanism only. So more than 2 pages. Yeah. So this is what makes improves the weightage of the paper by giving more part to the mechanism portion instead of just uh, giving information about the findings. So I think this was the main part of the paper. Now the third part is performance of the proposed antenna. So though the analysis in the previous section, through the analysis in the previous section, an enhanced radiation characteristic can be obtained by introducing SSPP parasitic element to Vivaldi antenna. Since they have explored everything and explained everything there in the previous section, now these are some conclusive statements they are giving here in order to confirm the performance. Now, so in the previous section, they gave reasoning and they said that by this is happening, by this that is happening. Now confirmation is here. So in order to confirm the performance, simulated S parameters of Vivaldi antennas with and without SSPP parasitic elements are compared. They have compared S parameters also just to confirm the performance they have achieved in electric field. So as shown in figure this, the original Vivaldi antenna works in the frequency range this. It is clear that our proposed antenna with the parasitic element has same work band, keeping the ultra wideband property. So they have justified by why they are calling it ultra wideband. The return loss is less than minus 10 dB in the whole band except at this frequency, which is about this. Then a prototype is fabricated whose measurement results agree well with the simulated one. So simple statements are there uh, just for verification. Now, in general, the bandwidth. Now here, the discussion start. This is an important part of this section. Performance of the proposed antenna. Here we should write these statements, these paragraphs. In general, the bandwidth of a traditional Vivaldi antenna is determined by the transition from the feeding microstrip line to the slot line and the dimensions of the antenna. Means how to calculate the bandwidth of the Vivaldi antenna. So they have discussed this also. This is an important part because usually we don't go deep in this field. Means people know that Vivaldi antennas provide better bandwidth, good bandwidth, but how and why? So they are trying to answer this question, how and why. The bandwidth of a traditional Vivaldi antenna is determined by the transition from the feeding microstrip line to the slot line and the dimensions of the antenna. These are some standard reasoning behind a large bandwidth of the Vivaldi antenna. The flare height and length need to be about half wavelength. So this is concept at low frequency end. At higher frequencies, the energy gets radiated into the air by traveling wave along the tapered slot. The taper factor also influences the impedance matching. Now, this is yet another important statement. Now, in this way, the Vivaldi can easily operate in the ultra wideband frequency range. So, this was, uh, this was, I mean, these 5 to 10 lines, 8 lines. So they have summarized things about Vivaldi antenna basics. Now, we always hope that the parasitic element can improve the directivity without compromising the ultra wideband of the original antenna. Do this. So they've just said that by parasitic element addition, their bandwidth should not be compromised. That's what they have written here. To do this, we should adjust the size of SSPP unit cell to make the bandwidth of the SSPP matching bandwidth of the Vivaldi. So that's what they have said, that in the analysis part, they had to make this adjust the size of SSPP according to the bandwidth. So that's what they have discussed here. Yet another important statement it is. To verify the radiation improvement by SSPP parasitic elements, the simulated gain of the Vivaldi antenna with and without SSPP patch are presented in figure 7b. So now again, very important statement it is. We should be writing it this way.